Before I jump into the main topic, here is an important detail. If you are preparing for a tech role, then you must choose a solid career track. Visit sanfoundry.com/training to know more. Dear friends, in this particular example, I am going to cover a very interesting problem. Okay, this is a very interesting problem. So let's look into this code, read it more carefully. Okay, you will see we have three integers x, y and then z, and we have initialized it with the value 0, 0 and then 1. After doing this particular expression, you are supposed to get the answers for x, y and z, right? X, y and z. So try to analyze this code. This is a very good code actually. Okay, this will allow you to understand in terms of your knowledge on C how you can write a good code or sometimes how complex a code is. Okay, so please pause the video and then please keep analyzing for a few minutes. If you think your answers are ready, then the next best is to run the code in your system, or you can also wait for me to jump into the lab. Okay, for some of you who are slightly new in this kind of topics, right, you have to understand that we have multiple things going on in this particular line. Okay, so we have multiple operations going on in this line, and based on the outcome of some of these operations, the entire expression will get evaluated or it may not get evaluated. Okay, so we have to see this kind of problems are always like this. We have to understand how things are working based on certain guidelines, and then we will try to see the answer. All right, so we are going to jump into the lab for this problem, and then I'm going to explain you a lot in terms of that particular line. Okay, all right, so here you go. We have a program 20, and in this program let me make it more readable first, okay, because this is really needed. So the most important line, as I told you, is this line. Okay, first let's compile this, and then we will eliminate any compilation error if there are any. Okay, so luckily we don't have any compilation error. Our code is still this. We are going to do a dot out, right? So when you do an a dot out, you might be surprised at some of your findings. Okay, so you are getting all the three of them as 1, right? All the three of them as 1. Now I will have two variations of this program for you to work on. Okay, so this was one variation, and other variation I wanted you, because this is a very classical example for understanding many things in C language in terms of evaluation of an expression. Okay, so I'm going to modify this code, and then I will do this with say 1, right? Okay, so originally it was 0, now it is 1. So my request is to pause once again this video, and then try to see, by changing this value of x equal to 1, do we really get some different behavioral output, or it is going to be same. When I say some different behavioral output, so x might become 2 and then both of them will be 1 or something like that. Okay, so what I did in this code, if you see, is basically, right, we have simply initialize the value of x equal to 1, and here it is 0. So these are the two code I am going to explain to you, one after another. Okay, so let me run this second code. It is program 20, right, this guy, right? So we will do a cc compilation on this, and then we will run this code. So when I run this code, will you get once again, it was 1 1 1, will you get 2 1 1 or something else? So you are getting something else, right? Okay, you are getting 2 0 1, right? So some of you who are still with me at this point of time, you will see that yes, it's fairly tricky actually. Okay, So let's see what's going on in this simple expression. I know it's not simple. For some of you, it may be complex, okay? But when you focus on C more seriously, more carefully, yeah, you will figure out that, you can easily solve this kind of expressions, okay? So first we will go to the first one, which is known as P20, okay, .c. So let's go ahead and try to, write one explanation portion for the behavior which you saw, right? So we will get started. We have x plus plus and y plus plus and z plus plus, right? Okay. Important thing for you to remember here is this expression is coming from operator precedence, right? So we have to think about operator precedence. In these expressions, you have lot of plus plus, it is basically all are suffix. It's a post-increment operation, and then you have binary operators like this, right? You can see that binary operator and binary operator. So the first thing is we put a bracket to solve the problem. I repeat, we need to put a bracket to solve the problem. And some of you might already know that we can put a bracket here. Why? Any guesswork? Because when you talk about operator precedence, logical AND has higher precedence than logical OR operation. So we are going to put the bracket here because this has a higher precedence, right? So you can see this. So now it is a simpler solution to look at, okay? So let's look into this. The value of x is 0. So we substituted 0 and then x became x plus plus, right? So ideally what is happening is we are substituting a value of 0 here and then automatically x has become that plus plus, right? So this equation, if I have to write it for the sake of writing, right? So I will just simply write like this, okay, so that you can understand it, okay? So it is 0 and then x has become already 1, as you know, okay? But this is 0 or another expression. So since you know that it is an OR gate, right? It's an logic OR. So OR logic says that if this is false, then I have to go and then try to solve this, right? So it will say I will go and then try to solve this, okay? So that's the reason at this point x has become 1, you know that, and then we are going to solve only this portion. So let me write this portion for you, right? So you do y plus plus, logical AND z plus plus, z plus plus, right? So again, what is the value of y? Y equals to 0. So it's a post increment, right? So it is basically poster, basically. So you supply the value 0 and then y has become y plus plus. So y has become 1, as you know, and this is the expression, right? Yeah, behind the scene y has become 1. We don't have to worry. Now watch carefully. We have substituted the value 0 and then we are trying to do a logical AND. So logical AND rule says that if one of the operand is false, there is no need for me to evaluate further because we know that it is already going to be a false. The outcome is always false. So it is known as short circuit behavior, right? So short circuit behavior implemented in the C compiler or the C rules basically, right? Okay. So this value is 0 and this is an AND gate. So we are not going to evaluate at all. Compiler will not do Z plus plus. Okay. But Y plus plus has already happened. So you can see that Y has become 1. But Z is untouched. Okay. So what was the original value of Z? Z is still, if you see the code, 1. Z is still 1. So what you can see eventually is x 1, y 1 and then z 1. And that is what you saw when you compiled this code and then when you run the code, right? So I think this is what. So you have to understand two things here. One is operator precedence and second is short circuit behavior as defined by the C language for logical operations. Okay. Now let's go into another code which I mentioned, and with this knowledge, P20 under this is another code, right? So whatever knowledge I have shared with you, whatever understanding I have tried to give, right? I think with that understanding, you should be able to solve this now. Okay, so I'm going to explain once again in detail about that second program now. Okay, So what is the second program? As a recap, I change the value of x equal to 1. That's it. And then I simply run the code. When I simply compile and run the code, I was getting the value 2, 0 and 1. This is very interesting. I did 2, 0 and 1. Okay. So let's see how it happened. Since I have already explained some of this behavior, I am sure that some of you will understand why the value is 2, 0 and 1, right? Okay. So let's take this once again. The first line eventually will be bracketed like this. So it's an operator precedence rule, right? Basically, operator precedence, and yeah. So you can see that this is the thing. Now the value of x is 1, right? So we simply substituted 1 and then we incremented. So when you see this, we are writing one OR operation like this, and then x has become 2 now because it's an x plus plus anyway. You can see that. Okay, but first we substituted. Now you know that for any gate, especially once again an OR logic or an OR gate, if one of the operand is already 1, you know that there is no need for me to evaluate the other operand or expression, right? Because the answer is anyway going to be true. One guy is true, right? You can see this one is true. So there is no need for me to even think about, evaluating. That is again a short circuit in terms of logical operations for a OR gate this time. Okay. So what has happened here is compiler says I am done. There is no need. Already this is 1. So x has become 2. I am not going to evaluate this. So y and z are unchanged. So y is still same. What is same? The value of y is 0, as you can see. And then similarly, z is still the original value 1, right? So this is 1. So with this, you can easily see that, by understanding the code. So x is 2, y is 0 and z is 1, right? So I am running this code. So it is 2, 0 and 1, right? So I think you fully understood this code, and the objective of this particular code snippet was for us to understand how do we evaluate an expression. So we have to understand some of the operator precedence and rules of associativity, definitely, and then also try to look into logic gates, and then if there is a scope for short circuit, right? In fact, when you do coding, right, we try to somehow figure out what. If the condition is true, then only we should do something else. If it is false, then don't do anything, right? So we have some of these choices, or we also use ternary operators many a times, in terms of conditional evaluation of our logic, actually. Okay. All right. So this video, I have covered only this much. In subsequent videos, I am going to go into different areas of C programming language and then try to come out with some critical areas for our discussion. Thank you very much.